Hello guys, welcome to Math Minders Academy. If you are just joining us the first time and you are here to subscribe to our channel, we urge you to hit the subscribe button and click on the notification bell icon so that each time we produce a new video, you'll be among the first to receive it. At the end of this video, go to the comment section and share your experience. Tell us what you feel about this video and let us know another area of mathematics you want us to make a video on. So today, guys, we are going to look at latitude and longitude part 2. In our part 1, we're able to describe all the features of the Earth, and we're able to say lines of longitude and the parallel of latitude. We also identify the equator and polar axis. So all of that, you can check them out in part 1 of longitude and latitude video. So in this part 2, we are going to be looking at distances measured along great circle or along the meridian. We're going to look at these distances. So here we'll be looking at where cities or towns or countries are, found in two different latitudes, but they are connected by a single longitude. When that happens, how can we get their distances apart, measured along this common longitude? So let's go. Now, when you look at the screen here, we're going to use a question, a specific question to demonstrate this distance apart, between two towns. So if you look at this question showing on the screen now, it says two towns both lie on longitude 25.9 degree east. Their latitudes are 31.6 degree north and 24.8 degrees south, respectively. Calculate the shortest distance between the towns correct to 3 significant figures. And we are giving, values of pi as 22/7 and the radius of the Earth to be approximately 6,400 kilometers. So I'm going to demonstrate this in 2 ways. First, I'm going to use a computer, to model this particular question so that it will aid our understanding, after which I'm going to now show exactly what a student is expected to do, drawing with pencil and putting all the necessary parts, required to properly give solution to this problem. So now let's look at it in 3D. We have our globe here. All right, and then this globe here, which is a sphere, represents the spherical nature of the Earth, and we can see the ring around, around about the center of the Earth, which represents the equator. All right, and we can also see a green dot that represent, that point is the center of the Earth. And so now we are going to look at the two latitudes given, that is latitude 31.6 degree north and 24.8 degree south. So we have these two latitudes. Okay, you can see each of them also come with their own specific centers, and these are small circles. So remember, we define latitude as small circles. So you can see one latitude going towards the north of the of the Earth, and the other one descending down towards the south or the southern part of the Earth. Okay, and now they are connected by a single longitude, and the longitude is longitude 25.9 degree east. Okay, so let's show this. So we can see the longitude 25.9 degree east. And so looking at this diagram, you will see how I run a line from the center of the Earth to the first latitude, which is the latitude that goes to the north, and then I run along another line which represents the radius, okay, connecting from the center of the Earth also down to the second latitude, which is latitude that has gone down towards the southern part of the Earth. Okay, so now at the end of this, what pattern are you seeing? You are seeing a pattern that looks like a sector. Okay, so at the end, we are going to find out that the distance apart will just be the length of the arc connecting, both towns. But again, another important thing we want to see is that if you look at it, you will see, an angle painted in pink. Okay, that describe the first, angle of the first latitude. So that pink angle represents latitude 31.6 degree north. And then we can see also the angle painted in green, which also represent the angle of the latitude 24.8 degrees south. Just like we mentioned in our previous video, that the latitudes are measured away from the equator. The equator is the reference plane, upon which each latitude drifts away, to any given angle. So they drift away, and then you can see also this angle showing their amount of drift away from the equator, which is the reference plane. Okay, so all of this beautifully depict the question given to us. We have modeled it in 3D, but of course, while writing exam, you will not have a computer handy to be able to model it. But this give us an opportunity to visualize what is expected. But in an exam condition, what am I going to do to be able to work out this appropriately? So I'm going to draw a circle. So I'll draw a circle here. All right, so let me give it this color. Good. Now I'm going to depict the diameter of the equator. So I'll use a line to show the diameter of the equator. All right, so we can see the diameter of the equator. Now let's look at another one. We want to look at the diameters of the latitudes given. So this is the diameter of the first latitude, which goes to the north. All right, let me put this there. So let's look at the diameter of the second latitude. Okay, so now I have this. Okay, now let's look at the diameter of the prime meridian. The prime meridian is the reference plane for all the longitudes, and it is 0 degrees. Okay, so we have this. All right, good. So now I'm going to draw. Of course, there are two things here. First, let me label. We have the north, we have the south, we have the east, and we have the west. Okay, so here, since I need to depict longitude 25.9 degree east, so I can draw that. So I have that now. All right. So all I now need to do is to connect draw the radius. Okay. So let's, from the center of the Earth, then now there's an intersection here. Let me show, I can show part of this arc. Okay. I can equally do the same here. Okay, so there's an intersection here. So this is intersection, this is another intersection. So let me call this term, let's call it A. All right, this other one here, let's call it B. So now I'm going to show the radius from here to this place. All right, let's take it. Now let's show another one from center to point B. Okay, so now the angle that helped to define the latitude going to the north is 31.6 degree north. So this latitude here is 31.6 degree north. So that's the measure of this angle. And the measure of this angle is the size of this latitude to the south, which is 24.8 degree. Okay, south. Then this is south, this is north. Okay. Now let me bring out, we can bring out this sector. We can bring out this sector, and we have A and B here. This is the radius drawn from the center. So we have this. And now let's check out the angular difference. Here, what will be the angular difference? The angular difference will be the total of that angle. If you look at it, the whole of this angle here is going to be 31.6 plus 24.8. And this will give us, if we add it up, it will give us 56.4. All right. But also note that the distance here, the distance is defined by the length of arc AB, which is theta over 360 times 2 pi r. This is the formula that defines the distance. So that means AB, finding the distance between AB will give us 56.4 over 360 times 2 times 22 over 7 times 6,400 kilometers, okay? And if you work on this, you are going to get 15 million. So you get 1588 2240. 40, okay, all over. If you multiply the denominator, you get 2520, okay? And then this is, if you use your calculator to divide, you're going to get 6,302.476 kilometers, okay? To three significant figures is going to be, of course, looking at this is a 4-digit number, looking at the whole number value or the integer value. So three significant figures, if you count the first three numbers, 630, the last one will not affect 0, which will turn out to be 0 also, to maintain the value of this entire number, which is in thousands. So it's going to give me 6,300 kilometers, okay? That is the value of the distance correct to three significant figures. So guys, I believe you understand, these solutions. Go back to the video again, watch it over and over. Try to work out this distance on your own and see whether you will get exactly this answer. All right. So this is how far we can go in this tutorial video. I don't want it to be too lengthy, but at least we've been able to get the important thing, how to find the distance between 2 points on different latitudes connected by the same longitude. If you find value in this video and you're yet to subscribe, we urge you to hit that subscribe button right away. Click on the notification bell icon so that each time we drop a new video, you'll be among the people to receive it. Go to the comment section and share your experience. Tell us, is there anything you feel we can do better? We want to hear from you, and also want to find out if there's any area of mathematics you want us to make a video on. We implore you to be with us next time when we be looking at part 3 of longitude and latitude. In that class, we are going to explore other questions that will help us to see distances when the points are connected by two different meridians. That is, they belong to two different longitudes, and then there's a common latitude. Okay, how can we find their distances measured along that common latitude? Why not make it a date with us when we have a class so that we can explore that together? See you in our next tutorial class. Bye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught